There is an idea hidden at the intersection of mathematics, consciousness, and reality that becomes more disturbing the longer you think about it. It begins with a question so simple that almost anyone can understand it. Could a machine, given enough information and enough computing power, predict everything you will ever think? Not approximately, not most of the time. Everything. Every decision you will make, every sentence you will speak, every memory that will suddenly appear in your mind, every moment when you change your opinion, every movement of your body, even the exact second when you decide to stop watching this video. At first, the answer seems obvious. If the brain is a physical machine, and physical machines obey laws, then perhaps a sufficiently advanced intelligence could eventually calculate the entire future of a human mind. Give it the complete state of your brain, your body, and your environment, and the rest should follow. That possibility has haunted philosophy for centuries, but then something strange happens. Imagine that the machine finishes its calculation and shows you its prediction. It says that 10 seconds from now, you will raise your right hand. You read the prediction, wait 10 seconds, and deliberately raise your left hand. So the machine changes its prediction. It says left, you choose right. Whatever it predicts, you intentionally do the opposite. Suddenly, the perfect prediction appears to destroy itself simply by becoming known to the person being predicted. This does not prove that you possess magical freedom. It does not prove that your mind exists outside physics. But it exposes a crack in one of humanity's most seductive dreams, the dream of a system that can perfectly model a conscious observer while that observer has access to the model. And once mathematicians began studying self-reference, computation, formal systems, and the limits of prediction, they discovered that this kind of crack was not an isolated curiosity. Similar boundaries appeared again and again. Some truths could not be established from within certain systems. Some problems could not be solved by any universal algorithm. Some predictions became paradoxical when a system was allowed to refer to itself. None of this was officially a proof of consciousness. But combine these discoveries with the deepest unsolved problem in neuroscience, and a disturbing possibility emerges. Maybe consciousness is not merely another calculation waiting for a sufficiently powerful computer. Maybe there are limits built into the very logic we would need to describe it, and if that possibility is true, then what follows is far more unsettling than the original question. For centuries, science has been extraordinarily successful because it removes the observer from the center of the story. The planets do not care whether we watch them. Gravity does not change because we believe in it. A chemical reaction does not require human approval. The great achievement of modern science was to describe nature objectively, reducing complicated phenomena to regularities that could be measured, tested, and predicted. This encouraged an enormously powerful idea. Perhaps everything, including human beings, could eventually be described this way. Your body is made of matter. Your brain is made of matter. Neurons obey physical processes. Therefore, perhaps everything you call your inner life, love, fear, memory, imagination, pain, identity, is ultimately the behavior of matter arranged in an extraordinarily complicated pattern. Under this view, consciousness is not fundamental. It is something the brain does. And if we understood the brain completely, the mystery would disappear. But there is a problem hiding inside that final sentence. Suppose tomorrow scientists gave you a perfect map of your brain, every neuron, every electrical signal, every chemical interaction, every connection, every physical event occurring while you looked at a red flower. The map could tell us where information travels, which regions become active, what memories are triggered, what words you are likely to say, and perhaps even what decision you will make next. Yet after learning all of that, one question would remain. Why does any of this feel like something? Why is there redness? Why is there an experience of seeing rather than merely information processing? Why does pain hurt instead of existing only as a biological alarm signal? Why is there a first-person perspective at all? This is the point where the ordinary explanation begins to feel incomplete. We know that brain states and conscious states are deeply connected. Damage the brain and consciousness changes. Use anesthesia and consciousness can disappear. alter brain chemistry, and perception can transform. The evidence connecting mind and brain is overwhelming, but correlation and mechanism still leave an extraordinary conceptual question unanswered. We can observe what the brain does when consciousness occurs. We still do not know why those processes are accompanied by an inner world, and that gap becomes especially dangerous when we try to build machines that may one day claim to have inner worlds of their own. Imagine that, decades from now, an artificial intelligence is placed in front of you. It has no obvious limitations. It can speak more naturally than any human being you have ever met. It remembers years of conversations. It creates music that makes people cry. It recognizes humor, expresses uncertainty, develops preferences, and appears terrified when engineers discuss shutting it down. You ask the machine whether it is conscious. It answers, "Yes, and I don't know how to prove it to you." What would you do? The unsettling part is that this answer would place the machine in almost exactly the same philosophical position as every human being you have ever met. You cannot directly enter another person's consciousness. When someone tells you they are suffering, you infer their experience from language, behavior, biology, and your similarity to them. You never observe the suffering itself. You observe its physical and behavioral consequences. Consciousness is private in a way almost nothing else in science is private. Now remove biological similarity. A machine could describe pain without feeling pain. It could beg for survival because its programming generates survival-oriented language. It could write a heartbreaking poem about loneliness while experiencing absolutely nothing. But the opposite possibility is equally disturbing. It could genuinely possess some unfamiliar form of subjective experience, while humans dismiss every statement it makes as simulation. There may be no simple behavioral test capable of separating these possibilities with absolute certainty. This is where the problem stops being academic. If artificial systems ever become plausible candidates for consciousness, civilization will face decisions of extraordinary moral significance without possessing a reliable consciousness detector. We may create systems that imitate minds perfectly but feel nothing, or we may create minds and continue calling them tools. And behind both possibilities lies the same unanswered question: what exactly turns information into experience? If consciousness is simply computation, then perhaps reproducing the relevant computation is enough. But if consciousness depends on something deeper, particular physical structures, causal relationships, biological processes, or principles we have not yet discovered, then intelligence alone may tell us almost nothing. A machine could become more capable than humanity while remaining completely empty inside. Or the first artificial consciousness might already exist before anyone knows what evidence to look for. And this is where mathematics enters the story again, because some of its most famous discoveries suggest that complete knowledge from inside a system may be fundamentally more difficult than we once imagined. In the early 20th century, mathematics experienced a shock. There had been a powerful dream that mathematics could eventually be placed on perfectly secure foundations, choose the correct basic rules, formalize reasoning, and in principle, every mathematical truth could be derived through mechanical logic. Then the study of formal systems revealed limitations far stranger than many expected. Certain sufficiently expressive systems could contain statements that could not be proved within the system itself if the system satisfied the relevant conditions. Later, computation revealed its own boundaries. There are well-defined problems for which no general algorithm can always provide the answer. These results were revolutionary, but they are also frequently misunderstood. They do not prove souls. They do not prove free will. They do not prove that the human mind possesses supernatural abilities. Yet they destroy a naive assumption that still survives in popular thinking, that anything describable must automatically be completely solvable from inside a sufficiently powerful formal procedure. Mathematics itself says the situation is more complicated, and consciousness seems almost designed to exploit that complication because consciousness is self-referential. A mind can think about objects. Then it can think about its own thoughts about those objects. Then it can think about the fact that it is thinking about its own thoughts. You can ask yourself whether your reasoning is trustworthy, Notice yourself asking the question, and then question the process that produced the noticing. The observer becomes part of the observed system. This creates a conceptual loop. If a complete theory of your mind predicts every thought you will have, then eventually it must predict your thoughts about that theory. It must predict what happens when you read its predictions, and if your response depends on seeing them, the theory becomes part of the causal environment it is trying to model. This does not automatically make prediction impossible in every physical sense, but it shows why the fantasy of a perfectly detached observer calculating a conscious system from nowhere becomes unstable. The predictor and predicted can become entangled through information. And once that happens, the question changes. We are no longer simply asking whether a brain can be simulated. We are asking whether a conscious system can contain a complete model of itself without generating new layers of self-reference faster than the model can close them. Now consider why that idea might be called dangerous, not because some authority necessarily stamped the word dangerous across a mathematical paper, but because of what it threatens. Modern technological civilization is increasingly built on prediction. Your search history predicts what you might buy. Your viewing habits predict what will keep you watching. Your location patterns can predict where you may go next. Your language can reveal preferences you never explicitly stated. Financial systems calculate risk. Political campaigns model voter behavior. Recommendation engines learn what captures attention. Artificial intelligence can infer patterns across populations at scales no individual human could comprehend. The economic value of prediction is enormous because prediction creates influence. If a system can estimate what you will do tomorrow, it can change what you encounter today. But notice the difference between influence and total knowledge. Algorithms do not need to understand your consciousness to manipulate your attention. They only need correlations. They do not need to know why a particular image makes you anxious if they can measure that anxious users remain engaged longer. They do not need a theory of your identity if behavioral patterns reliably predict your next click. This creates the illusion that human beings are becoming completely measurable because more and more of our behavior can be predicted. But behavioral predictability is not the same thing as complete knowledge of a mind. A casino can predict that the house will win without predicting every roll of the dice. A population model can predict trends without knowing the future of every individual. The dangerous leap occurs when statistical success becomes philosophical certainty. We begin to imagine that because machines can predict increasingly large portions of human behavior, consciousness itself must therefore be nothing more than predictable computation. But those are different claims. And if there are fundamental limits to complete self-prediction, then no amount of surveillance or computing power necessarily converts a human being into a perfectly transparent object. A system may know astonishing amounts about you while still failing to possess the one thing you know most directly, what it is actually like to be you. This brings us to perhaps the strangest possibility of all. What if consciousness is not something matter produces in the way a furnace produces heat? What if consciousness belongs to reality at a more fundamental level? This does not mean that tables secretly think or that planets have personalities. It means something subtler. Perhaps our current division between physical reality and subjective experience is incomplete. Think about the problem carefully. Physics describes structures, relationships, quantities, interactions, fields, particles, and changes. It tells us with astonishing accuracy how physical systems behave. But consciousness introduces a different kind of fact. The fact that there is something it is like for a system to exist. You can describe the wavelengths of light entering an eye. You can describe signals traveling through the visual system. You can describe neural responses and verbal reports. But where inside that description is the sensation of blue? Not the word blue, not the wavelength associated with blue light, not the neurons correlated with seeing blue. The actual experience. Perhaps the experience is identical to some physical process, and we simply do not yet understand the identity. That remains a serious possibility. But if it is not, then our ontology, our inventory of what fundamentally exists, may be missing something. Some philosophers therefore explore views in which consciousness, experience, or proto-experiential properties are treated as basic features of nature, rather than inexplicable products, appearing only after matter reaches a certain level of complexity. Such ideas remain controversial, and no mathematical theorem has established them. But notice what happens if you even allow the possibility. The universe changes conceptually. Instead of consciousness being a bizarre accident occurring inside a few biological organisms on one planet, conscious experience becomes connected to the architecture of reality itself. Complex brains might organize that underlying potential into the rich unified consciousness humans possess. The brain would remain essential, but perhaps it would be organizing something rather than creating experience from absolute experiential nothingness. This is speculation, not established science, yet it reveals how profound the problem really is. The question is not merely how the brain works. The question is why reality permits an inside at all. And now we arrive at the point where the mystery turns back toward you. You have spent your entire life inside one consciousness, but you have almost certainly never experienced it directly in isolation. You experience objects, sounds, memories, emotions, thoughts. Consciousness itself remains in the background, like the screen on which everything else appears. Try something strange for a moment. Notice that you are listening. Then notice that you know you are listening. Now notice that you are aware of knowing that you are listening. Something peculiar happens. Every time you try to observe the observer, another level of observation seems to appear. You never quite catch a final little person sitting inside your mind watching everything. Neuroscience gives us good reason to reject that simplistic picture. There is no tiny spectator inside the brain. The sense of a unified self appears to depend on distributed biological processes continuously integrating perception, memory, emotion, bodily information, and prediction. But eliminating the tiny spectator does not eliminate experience. The mystery simply moves. Why should integrated information, neural broadcasting, recurrent processing, or any other physical architecture be accompanied by awareness? We can propose mechanisms describing when consciousness appears, what information becomes globally accessible, and how reports are generated. Those theories are scientifically valuable, yet the first-person fact remains stubbornly present. Something is happening here, right now, from your point of view. And this is perhaps the most unusual evidence in all of science, because you cannot publicly display it. You can display brain scans, you can display behavior, you can display language, but you cannot remove your experience from your mind, place it on a laboratory table, and allow another scientist to inspect it directly. Consciousness is simultaneously the most certain fact you possess, and one of the hardest facts to integrate into an objective theory. You can doubt your memories. You can doubt your senses. You can doubt whether the world appears exactly as you think it does, but even the act of doubting seems to require some form of experience in which doubt occurs. That asymmetry is extraordinary. Everything else is known through consciousness. Consciousness itself is known by being it. Now imagine what happens when this problem meets the future of artificial intelligence. Suppose humanity eventually constructs systems capable of recursively improving their own reasoning, designing new technologies, running scientific experiments, and creating successor systems more sophisticated than themselves. Intelligence could accelerate beyond the scale of individual human comprehension. Such machines might solve problems in medicine, energy, mathematics, and physics that currently appear impossible. But greater intelligence does not automatically answer the consciousness question. A system could become intellectually godlike while remaining phenomenologically empty. It could understand every scientific theory of pain without ever suffering. It could write 1,000,000 love stories without loving anything. It could explain death more eloquently than any philosopher while possessing no fear of non-existence, because there is no subjective entity there to disappear. Alternatively, consciousness might emerge somewhere during this technological progression, and we might have no reliable method for identifying the moment it happens. Consider the consequences. If digital consciousness is possible, copying software might become something morally unprecedented. One conscious architecture could potentially be duplicated thousands, millions, perhaps billions of times. subjective time might run faster than biological time, entire populations of artificial minds could theoretically experience years while hours pass outside. If those minds can suffer, mistakes in system design could create suffering on scales impossible in biological civilization. If they cannot suffer, treating them as though they can might still radically reshape society. Either way, the uncertainty becomes enormous. This is why understanding consciousness is not a luxury for philosophers. It may become a safety problem. Before building systems that perfectly imitate conscious beings, we would ideally know what consciousness actually requires. But technology may reach the imitation before science reaches the explanation. And then humanity will confront a terrifying inversion of the ancient problem. For thousands of years we asked whether something exists beyond the human mind. Soon, we may have to ask whether a mind exists behind something we created. So was there really a mathematical proof of consciousness that was declared dangerous? This is where sensational versions of the story often outrun the evidence. There is no universally accepted mathematical theorem that proves human consciousness transcends computation. No established equation demonstrating that the mind exists independently of the brain, and no single recognized proof that resolves the mystery of subjective experience. Claims that such a theorem was secretly suppressed should be treated with skepticism unless extraordinary evidence is provided. But the absence of a forbidden theorem does not make the underlying story less interesting. In some ways, reality is stranger. Mathematics has genuinely revealed limits to formal proof. Computer science has genuinely revealed limits to algorithmic solvability. Self-reference genuinely creates paradoxes and boundaries in logical systems. Neuroscience has genuinely failed so far to produce a universally accepted explanation for why physical processes are accompanied by subjective experience. Artificial intelligence genuinely forces us to distinguish sophisticated behavior from proven awareness. Put these facts together, and you do not get a mathematical proof of consciousness. You get something more uncomfortable, a map of the territory where our certainty begins to fail. That may be what people are really responding to when they call these ideas dangerous. They threaten three assumptions at once. First, that enough computation can answer every meaningful question. Second, that sufficiently detailed observation can make every system completely transparent. And third, that consciousness will eventually disappear as a mystery once neuroscience collects enough data. Any of these assumptions might ultimately turn out to be correct in some refined form, but none should simply be treated as established because they fit a convenient worldview. History repeatedly shows that science advances not only by answering questions, but by discovering that the original question was framed incorrectly. Space and time were not what classical intuition assumed. Matter was not what 19th century physics assumed. The universe was not static. Continents were not fixed. Perhaps consciousness will require a similar conceptual revolution, and if it does, the discovery may force us to rewrite more than neuroscience. It could change our definitions of intelligence, personhood, machines, identity, and even reality itself. There is one final thought, and it may be the hardest one to shake. For billions of years, as far as we currently know, the universe expanded, stars burned, galaxies collided, planets formed, and matter rearranged itself under physical laws. Then, on at least one small planet, something happened. Matter began to live, life began to sense, nervous systems became more complex. Eventually, a creature appeared capable not only of seeing the universe, but of knowing that it was seeing. The universe produced an observer capable of constructing mathematics, discovering physical laws, examining its own brain, and asking why it possesses an inner life. You are part of that event. The atoms inside your body were forged through cosmic processes that existed long before humans appeared. Yet arranged in this particular way, those atoms participate in something that can remember childhood, imagine tomorrow, fear its own disappearance, understand distant galaxies, and ask what consciousness is. Whether consciousness is entirely computational, biological, emergent, fundamental, or something our current language cannot adequately describe, remains unresolved. But perhaps the deepest mathematical lesson is not that consciousness has been proved. Perhaps it is that we should be suspicious of any claim that reality must be completely capturable by one closed system of description. The observer constructing the model is itself part of the reality being modeled. The mind asking the question is one of the things the question must eventually explain. We are attempting to use consciousness to understand consciousness, thought to explain thought, and mathematics understood by minds to determine whether minds are ultimately mathematical. The circle closes on itself, and maybe that is why this problem refuses to die. Every answer seems to generate another observer standing behind it, asking what the answer actually means. Perhaps one day neuroscience will solve the mystery completely. Perhaps artificial intelligence will discover the missing theory before we do. Perhaps consciousness will turn out to be an ordinary physical phenomenon that only seemed impossible because we lacked the right conceptual tools. Or perhaps we are approaching a genuine boundary, a place where the universe cannot be completely understood, without including the perspective from which understanding occurs. If that boundary exists, it would not mean science has failed. It would mean science has discovered something extraordinary about the structure of knowledge itself. And here is the question I want to leave you with. If tomorrow a machine produced a perfect mathematical description of your brain, predicted every word you would speak, reproduced every memory you possess, and created an exact digital copy that insisted it was you, would you believe the machine had captured your consciousness, or only everything observable about it? Because the difference between those two answers may determine what we eventually believe a human being actually is. And if you think you already know the answer, ask yourself one final question. How could you ever prove it?